I'm Jennifer Queller, and today I shall be assembling a TLC plate. So this is the actual TLC plate that you'll be using. We're just going to set it aside for now. We will be marking it, but first we're going to want to pour in the developing solution first so we can see where to mark it so that the spots do not dissolve in the developing solution. So we're going to take the lid off.
I don't even know how to narrate it.
And we're going to take filter paper and put it in on the side of the jar. And then our developing solution will consist of 2 milliliters of ethyl acetate and 8 milliliters of pectins.
I'll put this up to the jar and see where, and then we'll get started.
Then you're going to take it and get the filter paper wet, as shown.
Tell me when you're starting.
You're just going to want to get it wet so that
Hear me in
this will keep the TLC plate, like it'll keep the solvent in there, and this will keep it from evaporating. You're going to want to put the lid back on it, so that way this is filled with the organic solutions vapor basically, so that it'll keep it nice and nice. So then you're going to take the TLC plate. You don't really want to touch this side of the plate as this is where you will be marking it, and you can kind of mess it up and make a mistake, and it'll affect how the spots move when they go up. So you're going to take it and measure, probably better on the flat surface. Then and then you're going to take it and draw a very, very light line on your plate, and then so that way when it's in, it will not touch the solution that's down there. And you're going to draw 3 little tick marks along that line. 2 little tick marks along that line. Because we're like testing 2 substances. You don't want them to be too close to each other, but you don't want them to be too close to the edges, or else that'll affect how they move and the solvent goes up in the plate. Yeah. So I think it's time to spot our plate. So I've marked my plate with the 2 substances we will be testing. We have fluorinone, which I marked with an O-N-E, and then we also have fluorinene, which I marked with an E-N-E. That way I do not get them confused while I am testing these substances. So this is the microcapillary that we'll use to be doing the spotting with. That one has no jagged edges, as well as this one over here for the fluorinene. So we'll be taking the fluorinone, my little microcapillary.
start off with like that.
And you don't want the dot to be too big, but you also don't want it to be too small. And you don't want it to be not visible to the eye. So I'm going to say that 2 times is enough for this. I'll put this back, and then I'm going to get my fluorinene. I'm going to take my little capillary and dip it in there. And I'm going to wait for it to dry. You want to wait for it to dry before you do another dot. And I'm going to say that's enough because it spreads very quickly when you do your dot. So for now, and you want these dots to dry, you want your spots to dry completely before you put them into your developing jar. So now, your tweezers, because you want to have your tweezers, so that you limit how much you're touching it. Well, first I'm going to screw the plate. That way I can put it in. Now, when you put this in, you want it to be as perpendicular as possible to the filter paper, and you do not want it to touch the filter paper. So, I'm going to put it this way so you can see. You're going to want to put it straight in. Oops. Here, we're going to grip it here so that I don't accidentally tip it. Now, this is normal, it'll happen, so you just kind of have to fix it. This won't completely mess up the result. Alright, so I put the lid back on. I do apologize for my language in the last video, if that was heard. I thought I messed up my sample. But as you can see, it is developing upward already. You can see it going up. Now you don't want it to go all the way to the top. You want to leave about like 5 to 10 milliliters of the plate left at the top so that you can measure it for your RF value. So you just kind of have to eyeball it here as it's absorbing up into it. Oh, somebody set their hood off. I don't really know how long this will take. Oh, it's going up. I can see it going up. It's kind of weird too. I don't know if this is somewhat of an error the way that the plate works, but it is kind of at a, you can kind of see the horizontal angle at which it's like absorbing the developing solution upward. Or that's just the jar, can't really tell. Okay, I think we're getting close. That looks, I'm gonna let it go a little bit longer.
I gotta take my phone. You gotta record this for me. It's already
So, there you can see it on the camera. It's becoming more even now. It's not as crooked. I guess that was just the initial rate of you going up the filter plate. So I'm gonna take it out now because that's about 5 to 10 milliliters. Again, using your tweezer. As you can see, it's really hard to tell where it goes. So once you do this, you're gonna want to lay it down, and where you see the solvent, you want to draw a line across, just like that, so that you can see where it ended. Then we're gonna take our paper and we're gonna go and look. I'm gonna put this back on. Oh, sorry. We're gonna take it over to the UV light so that we can see. It'll be what is considered a dark spot somewhere in the middle of the plate, and that is where we will use to get our RF value later. So I'm at the UV light. I'm gonna put paper.
And then you can see where the spots ended up.
Under. I don't think that's the right side. Let's see if. There it is. So those are our 2 spots for our samples. I'm gonna take the pencil and just lightly go over each spot for each one, and that's it. Oops. All right, so now it's time to measure for our RF value, and what an RF value is it's a ratio of the distance that the little the substance that we're testing moved up compared over the distance that the developing solution moved up. So For our first one, I'm going to take the little ruler here. Where's the one? Oh, here's the one. We're going to measure it. And when you measure it to the dot, you're going to want to measure it to the center of it. So I'm just going to put a slight little dot there so I know. I'll put a dot over here too for when I measure it later. So I'm going to say it's about, let's see, 1.5. It's kind of in between my markings here, so I'm just going to round to 5, 6, 7. I'm just going to round to 1.7. And I believe that is in centimeters. And then, so that's the first one is 1.7 centimeters, and the second one to the middle, it's like exactly 2.5 centimeters. And then the total height for what we're gonna do, I'll measure it to the middle since it's a little crooked here. I'll do the middle to the middle of this, which is just under 4, so 3.9 centimeters. So I already wrote down my measurements right here for the RF values, and this will be for the O and E value, 1.7 centimeters over 3.9. We'll get
Because of
this.
we should use Tyler's phone because we can pause.
0. I'm going to carry one extra significant value for this. That'll be my ratio. And for my other one, 2.5 divided by 3.9 will get me as my ratio. And for this experiment, the ideal value for RF is 0.2 and 0.8. So both of these values are ideal and they do make sense for the experiment. And that's it.